Railway Conversations with Doc Frank.
Hey, I'm Doc Frank. Welcome to my podcast where every week I'm presenting you authentic, spontaneous and unrehearsed discussions with interesting guests from the rail industry about topics that matter. Make sure you subscribe and tell your friends about it, as this podcast will both educate and entertain them. Thank you for listening. My guest today is Xavier Ricco from Mons in Belgium. Xavier is one of the foremost experts in ETCS testing tools, and accordingly, I used the opportunity to have him as a guest to talk about just that. And as it turns out, it's not just about testing of ETCS. These tools developed by his company Multitel can also be used for similar systems to ETCS, and that has been proven in countries such as China and South Korea, not exactly the easiest markets in the world. We also talk about the interoperability challenge with ETCS in Australia. And I finish with asking him for an assessment how he sees the level of interoperability for ETCS in Europe, something that's pretty close to my heart, where I think a lot of people have very optimistic expectations that are not quite often true. I hope you enjoy. Hi, it's Doc Frank. Real quick. If you are a fan of communications-based train control or short CBTC, there's an event coming up in September that you absolutely don't want to miss. It's the first virtual global CBTC conference. It's called CBTC World Summit 2023, and it's happening on the 20th and the 21st of September. There will be 3 sessions of about 6 hours duration each for 3 different global regions, one for Asia Pacific, one's for North and South America, and one's for Europe and the Middle East. So wherever you are in the world, one of those sessions will be during the daytime in your time zone, and you can watch it live for the full 6 hours with 6 presentations. The kicker about this is that all other presentations, including the ones from your own session, will be available for replay via recordings. So that means that if the other session should be in the middle of your night, you can still watch it on demand at a time that's more convenient for you and doesn't interfere with your good night's sleep. The conference is available for registration right now at my training portal under docfranktraining.podia.com/summit23. I repeat that, docfranktraining.podia.com/summit23. I'm putting a lot of effort into this conference. It will be an absolute blockbuster event, and I very much hope to see you there. Xavier, welcome to the show.
Yes, thank you, Frank. It's a pleasure to be with you today.
It's my pleasure as well. I'm very keen to have you on this conversation because from what I can see, I don't think there are many people on this planet who understand more on the topic of ETCS test tools than you do. And whether you know it or not, ETCS is a big topic here for us in Australia. And no, I don't want this entire conversation to be about Australia because I do have a global audience here. But I think if we can steer the conversation about ETCS in Australia, it will also be transferable to other countries, I hope. And you can probably tell stories in Europe where you transferred stuff from one country to the other. Yeah, maybe we start with this. Just tell us a little bit on some things that, I mean, I don't want you to talk 3 hours about it, but just give me a couple of examples of what your company Multitel has recently done on ETCS test tools and ETCS test implementations, if you can.
Okay. So in fact, it's we have been working on this notion for a while, since I would say 2000. I started myself in 2006. And in that context, we were not necessarily understanding the test topic and the TCS topic. In that area, we started to meet a series of existing laboratories that had their place for a long period in time, and they had shared with us their knowledge, which bring us deeper understanding on how they work, and with the vision we had and the capability we had, the capability to finally enforce the way the tests were performed. So just to give a bit of context, in fact. So at a point in time, I was involved myself in a learning curve through the well-known lab called CEDEX. You may know them.
Yes,
and
Spain.
also DLR,
yeah.
and also DLR as well in Braunschweig. So I could have the opportunity to visit them and learn their way of working. And I was involved in the working group in the very beginning to design and update the baseline 2 test from 222 to 230, then from 230 to 230D. And that was my preliminary experience. From that point, we started to dig into development of validation tools. That was our deep first experience. And with, let's say, third-party products, and we studied that product, we understood that, how it works. But the problem we had, that was we had to be, ISO 17025 lab. It was one of a piece of challenge we had to face in our history. And in order to have control and independency, which is the key element there, we needed to develop our own tools. So we started to complement what we had, which was missing there, with validation tools. We incorporated a camera to acquire the display that we were visualizing on the ETCS part, to qualify whenever the display was doing the right job or not in a black box testing principle. And then we extended this tool to finally the essence of the test bench, the heart, the capability to gather data from the device under test on the one hand, to register every information getting from out of the device under test in isolated mode, and then to validate based on the data, on the tools we already developed upfront, to validate the behavior of the tool. So our deepest experience in this area remains on the validation. And these years of experience we had brought a series of let's say innovation, because we come from different departments in multi-tele where you have electronic, you have computer science, you have signal processing, and so on. And this merge of competencies, multidisciplinarities, brought where our tools where they are today. So just to answer your initial question, I know that I started with something different, but just to answer your initial question, we spread around different areas in the world, and thanks to the innovation we had, thanks to the automation we brought to our tools, we could reduce a test campaign, traditional test campaign, baseline 2 test campaign. So just to start with the kickoff, which was lasting 9 months to manually verify steps, the DMI, display, blah blah blah, down to 1 month. Thanks to the automation we brought, thanks to the fact that we brought repeatable, reproducible, without human factor as much as we can in the loop. And that was the first, let's say, the first score we made there, I would say. We really beat the challenge of optimizing the process, reducing time, and bring in the end what the client wants. He wants its test report as fast as possible, because otherwise it will slow down the whole process. In fact, that's one thing.
So just to summarize this and to make it clearer, to make sure that I have understood it, and also for the sake of the listeners. So the suppliers in ETCS, I assume, have their own test tools. Not just I'm assuming, I know they have their own test tools because I used to be a product manager with one of the global ETCS suppliers as well. So they do their own in-house test, and then they hand over their products to the client saying these products are okay, they work as they are supposed to. The client says, oh, wait a minute, we need some kind of our own validation of that. We need to make sure independently that they really work, that the way that you say they work. They can't use the same test tools as the suppliers because that would obviously lead to the same results, whether they are right or wrong. So the task was to create an supplier independent set of test tools to have basically checks and balances against the test results from the suppliers. Is that so far correct?
Yes, it's perfect.
Okay,
Perfectly
good.
correct.
And in doing that, I mean, previously, from what I understood you to say, is that previously the client organizations did those tests manually, more or less, because they didn't have any tools, or they didn't have any good tools. That was very time consuming. And by using the tools that you developed, some of those testing processes could be reduced by about 90%. So if you say from 9 months down to 1 month, there, I think that's a reduction of, I don't know, 88% or something like that. So that's pretty.
That was for the baseline 2.
Yes.
And for the baseline 3, there was a deep change from the working group in terms of testing strategy, because baseline 2 was really long scenario. It was lasting about 40 to 45 minutes each. And when you had an issue at the very end of the test, you had to repeat again from scratch the test with human factor in the loop. So if you are missing an icon acknowledgement, or because sometimes you do not have to acknowledge, so you have to think also the opposite way, or that you are expected as human being not to acknowledge the icon to determine whenever the system breaks, something like that. So it was very painful process. So with the robot, it was really leveraging the process. And later on, the working group, where we were still involved in, decided to rework the process in a way that in the end we had shorter scenario, like maximum 10 minutes, but 5 minutes average. And with repeatable process, like preparation of the test, and then finalization of the test. So very efficient process, very optimized process in the end. And this was bringing then a better performance even for the baseline 3 tests themselves. So we started with baseline 2, average 44,000 steps to check. And in baseline 3, it approximately doubled, so 90,000, 98,000 whatsoever. And for the 90,000, we reduced it from down to 3 weeks.
Wow. So you still reduced your testing times, even though the number of test cases went significantly up. Yeah. So again,
exactly.
just as an explanation for the listeners, baseline is a version of the ETCS standards. So baseline 2 is basically a summary of all the older versions of the ETCS standards, and baseline 3 was a major change, a major step up in the functionality of ETCS. And I also believe, as you just said, with regards to the testing procedures, it was significantly streamlined, because when you took the lessons learned from the baseline 2, from the different versions of baseline 2, one of the things that came out loud and clear, I believe, was that the whole testing process was way too onerous, way too time consuming, and just not practical if you want to go forward for a rollout of ETCS across the entire continent. Yeah? So,
exactly.
but at the same time, interestingly, baseline 3 also added a lot of additional functionality. So that's where you said the number of test cases went up. So you wanted to streamline the test, but at the same time you pretty much doubled the number of test cases. So I think that was quite a challenge, but apparently you've done quite well. If you say twice the test cases and you still reduce your test effort by another 25%. That's quite an achievement. Yeah?
Yes, the automation, the use of robot in the end was in the end it works 24 hours per day, 24/7, voilà. And in the end, we we also reduced the human factor in the process. So that's definitely what we are always challenging in our context. There is always a risk there, and one interesting topic I always share when I try to expose what we do is we put, instead of using one single camera to monitor the display, we have two cameras. The reason behind is the fact that we started first with one camera, and when we put our hand in front of the icon that change, we need to repeat the test again because we have hidden the evidence that we have to validate. That's one thing. So we put two cameras and we develop strategy to recognize the display, to perform, to see through the arm of the robot itself. But it started with the hand of our operators, in fact. And this is more than 20, 12 years of development in the background that we improve regularly, in fact. And in the end, we started first it's public, so I can share that. We started first with certifying famous Japanese company called Hitachi. It's public, that's why I share this. And they acknowledge, they recognize the fact that we really beat the score on the performance. We could reduce their test campaign down to 1 month only. And in that context, they wanted much more than only going to the lab. They wanted some tools, in fact. So that was the kickoff for us to determine the fact that, in the end, the validation tool we brought are valuable for our customers. And then we need to somehow start to sell it. And that was another story, in fact. The aim of this was to prepare, in the end, the end customer, to be ready for the exam. So it's like a pre-test phase, and they have as many time they want to exercise their system. And because of the fact that we optimized it, it was really bringing added value for them. So it started with this, and I had at that point in time to teach a series of people in Japan, in Mito, to use our tools and to adopt the method that we put in place there. It was quite hard to share that experience, but it was a nice experience because I was at the beginning of my testing career, I would say. And it started to become something really interesting to share. And in the end, we also had a certain demand also on the Chinese market.
So if you say Hitachi, you mean the Japanese Hitachi. So not these days where they have acquired what used to be Ansaldo STS. So the Japanese Hitachi when they entered the European market with their ETCS products, right?
Exactly, yes.
Yeah.
So that they built in-house in Mito in Japan, and they had a need of testing their products, and they had something like a need to be accompanied sometimes also on some hot topic that were unclear in the norm itself, in fact, a series of gray area. And that was very, let's say, deep experience we started with in that context. But Japan was the first. Chinese were following because they wanted also to adopt a certain series of tools to verify their equipment. So we had to interface with 3 different trackside suppliers there, and we started also simultaneously to spread in Korea, South Korea. We went to we entered into the Korean market, and we started to develop a series of tools to adapt our existing tools, which were GSMR based, to the LTER based communication. So that was a very deep rethought of our architecture, but in the end, we had thought better our solution to be flexible enough to adapt to different capabilities. So the Chinese market first was for the CTCS. So we had to adjust the tools we developed to the CTCS domain. It was very complex because the architecture is very different from the European system. But we made it. And we had to also, interface with different trackside suppliers in China, where they have their different CBI interface for the trackside part. We also had to adjust to the CTCS domain for the different tools we developed, including the simulation of the CTCS itself, because that's also a key element we developed. Is our last market we recently had is in the UK. I will talk slightly about it later on, but we started first with the onboard testing, and then we started to diversify in different, let's say, gaps that were not necessarily answered, in fact. And in terms of gap, there is one example that is easy to understand, the trackside itself. There is nothing on the TSI itself that is explicitly expressing how to test an RBC, how to test a trackside as a whole, in fact. So we had to develop this culture of testing trackside aspects and to even introduce a new methodology there, in fact. Because if you think about EVC testing, it's IO-based testing. So you are the EVC, you are receiving stimulation, and you produce output. That's the IO-based approach. And in the end, the scenario, a sequence, has a distance to follow, and the event shall match the distance in terms of expectation with a certain window of observation around it. That's how it works. But then, when you transpose it to the track side, the story is very different, because you have, for example, handover process between two RBCs. If you stick with IO-based approach, you cannot answer the need of distance-based, it receive input, produce output. If it plays the role of handing over RBC on the one hand, and then on the other hand, it plays the role of accepting RBC for the same device under test. So we developed a new method, which was really drastically improving the process to work with, we call it flow-based approach. So in the end, it's device-to-device communication. So we have RBC accepting, sending a message to RBC, HOV, and vice versa. And all the methodology we had learned on the EVC part, we extended it to the track side. We extended it to the ATO, because we also developed ATO testing for the Korean market, because in practice, they wanted to test their ATO on board and their ATO track side with a test bench. There was nothing yet, in terms of standard available for that. It's under preparation for the baseline 4 itself. But we already anticipate that, because we had this demand from the Korean market to test their ATO systems. They were coming from the CBTC industry, and they wanted to adjust it for the ETCS industry, in fact. So they opened their protocols. We adapted our tools to connect to their ATO systems. And then in the end, it resulted into a ATO test bench of onboard and trackside. And recently we updated with the European flavor, in fact. So that's what we completed recently.
Let me just summarize this again, or dwell a little bit on this evolution of capabilities. So you came from Europe with an ETCS test capability. Then you went to Japan. You worked with Hitachi, which was also ETCS according to European standard, but a non-European supplier, which was already some kind of change. Then you took into China, which has CTCS, which is a Chinese train control system, where everybody thinks or says, it's pretty much the same as ETCS, just the levels are different. But as you just said, the devil's in the detail. If you look at it from a testing perspective, which needs to be very precise, you will see that the functionality is not exactly the same. Yeah, but
just to recap on that. I'm sorry.
Yeah, but you were in a position to basically take your existing ETCS testing capability and adjust it, adapt it to capture this Chinese capabilities. Then you go to Korea, which I believe has nothing to do with ETCS at all. Yeah, but is again a different system, and it's using a different radio system on top of it, which is LTE-R for railways.
Exactly.
As opposed to GSM-R, which is the standard radio for the European ETCS. So I find it quite impressive how you basically expanded your testing capability and eventually even brought it back to Europe after doing the ATO test capability in Korea, saying, well, now Europe is starting out with ATO over ETCS. And guess what? There are similarities. So you can basically take the capabilities from ATO testing in Korea, can adapt it again, and now it fits to ATO over ETCS in Europe. I think it's a fascinating story, which just required you to have products or to design your products in a way that they are adaptable according to client requirements. Yeah.
Yes, and we worked effectively on an asset-based approach. So it's like the core system works as a traditional approach. So you have the management of the moving of the train and so on. And in the end, when you talk protocols, it's a database. So if we want to come from baseline 2 to baseline 3, it's a database change. But the heart of the system is modular enough to easily adapt to any system that will need to be plugged in fact. That's the approach. Just one remark on the CTCS. The major differences when you look to the different architectures is, on the one hand, Europeans have the tendency to have all the rules to come from one level to another and so on, which brings a lot of engineering rules aside of it, I would say. When you go to CTCS, it's something like they thought their system in that way. The level 2 is working, and when we switch off, it falls back on the level 1. So there is no reason to manage the transitions, the level of complexity where you have the boundaries, from one level to another. Both work in parallel, in fact. So it's really amazing what they did there, in fact. But it's always something. It's easy for newcomers, I would say, and just say this way, because they observe the weakness of an existing standard or an existing something, and then they do something different.
It's really
effectively.
It's really interesting, and just as a side remark, the Chinese had for many years a reputation of basically just sucking all technology from Western suppliers and copying it. But what they've done, both in the field of CBTC and also what you just said in the field of CTCS, which is the ETCS equivalent, they have really used that knowledge that they gained to develop something better. So in the CBTC world, they looked at all the shortcomings of the Western CBTC standards, and one of them being lack of interoperability, another one having a suboptimum radio solution, which is Wi-Fi, and a third one having no proper standardization of automatic, of unattended train operation. And then they created a set of standards specifically for CBTC in China, which addressed all those shortcomings. So you now have standards providing for interoperability between different suppliers. You now have standards which are prescriptive regarding LTE radio, which is a much better technology for CBTC than Wi-Fi is. And you also have a standardization with regards to unattended train operation. And for CBTC, not for CBTC, sorry, for CTCS, you just reported something similar, that they looked at what came over from Europe, how does the European system, how does ETCS work, but then they developed some improvements of that, for example, which got rid of the need for level transitions. Yeah, and had an inbuilt fallback system. It's really quite amazing. And the next step then is, and I think they're already working on this, or they have been working on it for years, is to bring CTCS and CBTC together and basically create interoperability between those two technologies.
Exactly.
And if you try to translate this back into the Western world, like bringing together ETCS and CBTC, everybody says, "Oh my God, this is impossible." Yeah, but
it is almost happening. I would say it's step by step.
But
it's starting to happen.
But it's still very difficult because there are so many differences. And there was a research program in Europe, I remember years ago, where they looked into the possible convergence of ETCS and CBTC. And everybody was talking about this. Everybody was excited, like, we can bring together those two worlds. So they put in years of research effort. And the end result was that both technologies have about 20% of functionality in common, and everything else is just completely different. So there's no way we can bring it together. So that was the outcome a few years back in Europe. And I think the Chinese have approached this much more strategically. And I'm pretty sure that when they started developing the standards for CTCS, they already had in mind that once this is running properly, it needs to be brought together with the CBTC standards. So the entire approach was much more strategic, looking much more beyond the horizon, like looking at the entire railway infrastructure in China and to say, okay, well, how do we bring this together? But I didn't want to talk so much about China. That was more like a side remark. Where I would like to steer this conversation out of personal interest is really towards Australia. We have several city railways in Australia, not just city railways. We also have a couple of railways outside cities that are introducing ETCS. We have some applications of ETCS level 1. We have some applications of ETCS level 2. And we also have a few, I call them derivatives of ETCS, where a system is basically customer specific, but it's based on ETCS componentry. So there's a lot going on here. And one of the recent trends that's emerging stronger and stronger is the whole topic of interoperability. Interoperability is, of course, a hallmark feature of ETCS. That's the entire point for having a single system for automatic train protection for the entire European market, that it has to be interoperable between different countries, between different railways. Now, we have a similar concept or similar problem, if you will, in Australia, where we don't necessarily have different countries, but we have different states. And those different states historically have developed quite different railway systems with very different operational rules, with different signaling principles. And now if those different signaling principles flow into ETCS applications, there is a risk that those ETCS applications will be different as well. At the same time, we're saying, well, we're doing ETCS in Brisbane, we're doing ETCS in Sydney, we're doing ETCS in Melbourne, we're also doing ETCS in Adelaide. So basically the four biggest cities along the southeast of Australia, along the coast, all have ETCS. And the politicians that fund those projects, that spend the money for ETCS, will have no empathy whatsoever if these ETCS applications don't work together, if they are incompatible. So interoperability between those different ETCS applications is a very important topic at the moment. And from my perspective, this is very similar to the early ETCS problems in Europe, where you had, for example, an ETCS application in the Netherlands, and then you had an ETCS application in Belgium, and then you wanted to run a train from the Netherlands to Belgium and back. And suddenly you realized you had a border with two different ETCS coming from two different sites. Everybody thought, well, yes, but ETCS will be interoperable. Then you put them together and it didn't work. So you needed to put some work in to make this really an interoperable connection. And I think this is required for the applications in Australia as well. Now my question for you would be, based on your experience with ETCS testing and ETCS testing tools in Europe, in different European countries, what would you see necessary to make this work in Australia? Or in other words, how could Multitel or a company like Multitel, I don't know how many other suppliers are there like you for testing tools? I don't think very many, but what could Multitel do, or the tools that you have, to facilitate this journey in Australia towards interoperability? Sorry, very long question, but
no, it's a good question. And I would say it's interesting because it will be there is a deep link on our last big contract we won in the UK, in fact, for Network Rail. And in that context, they have this need of interoperability testing to bring suppliers connected to a lab, so that they check whenever the area of use, the line itself, is valid. So and they can somehow support the homologation or certification process around that. So they spent a series of money there for 10 years in order to equip a lab with Multitel tools in the end, in order to record the dialogue between the devices that will play the role of the final delivery stage. So this was a bid we won 2 years ago approximately, and we had to deliver to them a system level test where we connect, on the one hand, a real onboard, on the other hand, a real trackside. And we, in the middle, had to develop what is so-called a TCL, test control and logging system, that will record the data coming from one and going to the other via a radio bearer system. So that was globally what they were expecting there. Before going to this bid, we had won another bid in Korea. And it's very important to explain that. In the center of the system, we had to put a kind of TCL, but it was not yet a TCL. It was more proprietary-based system. But we had to think about connecting 3 RBCs on the one hand, and 2 EVC, or they call it today KVC, for Korean Vital Computer, on the other hand. The fact that they call it Korean Vital Computer is because they have this LTER-based communication and no more GSMR-based communication. So that's what they call in Korea. But in this context, the purpose was to mimic, let's say, to have a kind of digital twin of their pilot line, which was 180 kilometers long, with 25 different interlocking systems in the background, and to perform two simultaneous handover over it, with the physical real constituent on the other hand, the real EVCs, connected to the lab. So in the end, we developed that, we delivered that, and this served our let's say purpose to have a system which was adequately scaled, I would say, to answer multiple suppliers' connectivity. So the heart of the system was the system level test bench that we developed for the UK had a kind of how can I say, inherits from the experience we had in Korea, where we had to meet performance criteria. 60 simulations, we had to put 60 virtual trains on it to test the line and so on. It was very painful moment for us, but it was very extensive work, but it has served the purpose of UK in the end, because we brought them an optimized revision of the system. We started with Korea. And this approach is very interesting, because in the end, if you think about Brisbane, Sydney, Melbourne, they adopt a test bench, a lab for their trials, interoperability trials, with their specificities and their operational scenario. It's something that is that we can accompany in some way. We could accompany in some way by having a central system that connects all labs all together in order to determine whenever there are interoperability issues and determine whenever the compatibility is there. So it's something which will avoid, painful homologation phase with issues on the field and so on, and anticipate and download it into the lab to make it, let's say, cost effective, in fact, because you spend less, you do not spend the money to rent the line, to rent the train, to bring a series of engineers in the train and so on, to find in the end an issue on the field.
Yeah, sure. And I mean, the thing is, whenever you do testing in the field, you need to shut down your railway. And I think this is really the biggest problem. Yeah, because that's not good for the passengers. Then you come up with something like bus replacement services. Nobody likes that. And what the passengers will learn from that is that the railway is unreliable. The railway doesn't run whenever they need it to run, and then they may, in the worst case, find alternative means of transport. So what I see happening is, we have ETCS applications. So I just look at Brisbane, Sydney, and Melbourne. Melbourne at the moment doesn't have an ETCS application. They are thinking about it, but that's more something for the future. So at the moment, I'm just looking at Sydney and Brisbane. In Sydney, we have two suppliers of ETCS trackside at the same time, which are supposed to develop an interoperable solution where the two trackside solutions of the two different suppliers are interoperable and compatible. And then on top of that, they have up to 4 different onboard suppliers, so suppliers of ETCS equipment on the train that, of course, need to run on either of those two trackside solutions. So we basically have a 2x4 interoperability challenge, and trying to do all these tests 100% in the field exhaustively it's just not possible. It's way too much. So what I would see there is you would need to have a test bench specifically for Sydney, which reflects the specification of the client, and then basically verifies if the actual trackside developments of the two suppliers are in line with those specifications. So that's one application that I would see, that you test the trackside applications on compliance with the client specs and also on interoperability at the same time. Then the next step is, once you have this test bench for trackside Sydney, to use this test bench for interoperability testing of the different onboard systems from the suppliers. So, and if this is all working fine, then you basically have a proof of interoperability within Sydney, just within Sydney, trackside suppliers, onboard suppliers within Sydney. In Brisbane at the moment, it's a bit easier because they only have one supplier for the trackside and the onboard. So there's not much interoperability testing necessary. But in the future, there may be a second supplier coming into the Brisbane market, in which case you would very much need interoperability testing. Or the next generation of trains could have a different onboard supplier, something like this. So in the same way where you would have to want to have a trackside test bench in Sydney, you probably also would want to have a trackside test bench in Brisbane. And in the future, when Melbourne comes up with ETCS, with a specification, guess what? You will want to have a test bench for ETCS in Melbourne as well. So, and now the thing kicks in that you just mentioned. Once you have a test bench for Brisbane and one for Sydney and one for Melbourne, you can daisy chain those three and then basically have an interoperability testing of onboard systems on all these different test benches, because at the end of the day, interoperability means nothing else that a train with an ETCS onboard system travels into somebody else's area with an ETCS trackside system, and it needs to work. And
exactly.
Everything needs to work. So you basically need to do a 100% test, but you can only do a 100% test if A, you have a test bench that has 100% of the functionality, and B, you need some kind of an automated offline process, because otherwise you're testing yourself to death on the operating railway, and that means shutdowns left, right, and center, and everything comes to a stop. So is that kind of how you would see it? How this whole system would have to be set up?
That's exactly the, let's say, the transposition of what I had in my mind. That you made it adequately. You exposed adequately from my side. So it is exactly that. And the what is a nice, interesting topic is that the fact that the test bench that we use in isolated mode for the device under test, so the onboard, or the test bench that we use for the trackside to isolate the trackside and test the trackside. So that's a subset we developed on our side. And this test bench, they are used themselves as a connector in the system level test bench. So what is very interesting is, imagine that you do a test at system level and you find an issue. It can happen. But then you can discriminate. It's an issue on the onboard side. Okay. But then you can switch down to the isolated mode. So the traditional approach where you just test the constituent in isolated mode with the subset 76, subset 94 traditional approach, I would say. So we have this capability to involve somehow, on the one hand, the test bench testing the device under test in isolated mode, and on the other hand, to let's say to put a switch on this test bench so that it is becoming a connector for the system level test bench. So it serves the purpose of both. And what is also a kind of key advantage we brought there is the fact that because we had to automate the test for the subset 76 with our robots, we have then all the necessary, let's say, knowledge, configuration management that we can recycle when we talk to the system level, so that we can even automate the system level tests itself. And this is a success story we have today in the UK, in fact. They recognize that. At the lessons learned at the end of the project, explicitly said it was the least painful project we have ever had. And when we received this from them, it was very positive, in fact.
Before I let you go, I'm conscious of the time. We're kind of running out of time, but we probably, well, you could probably keep talking for hours. I can see that clearly, and it's extremely interesting, at least for me. I hope for the listeners as well. But before I let you go, I just need a statement from you as an expert on ETCS testing in Europe, and also related to that, a kind of expert in ETCS interoperability in Europe, and because you basically see in your test how much interoperability is there and how much is missing. I believe we still have people in this country here, and maybe in other countries as well, that basically think whenever the four letters E, T, C, and S come in, interoperability falls off the tree. It's there by default. It's there naturally. And I every opportunity I have to talk to somebody from Europe or have somebody from Europe talking, is to basically clarify this is a myth. This is not reality. So if you can give us a quick statement, how natural is ETCS interoperability in Europe, and how much work is actually required to achieve interoperability in practice? Is that kind of, you know where I'm coming from? So how hard is it? I rephrase it. How hard is it to make the interoperable ETCS really interoperable in Europe, in your experience?
If I look at the, let's say, the different systems we had to integrate in our labs to certify them, it's about 25 different onboard suppliers. We had to interface them with our system, and we had to determine whenever they conform to the norm. Most of the work we achieved there was, to identify whenever there was an issue on their development. In fact, and it's not always 100% perfect. It's impossible, in fact, because there are so many parameters, so many, let's say, steps to check, even from the fact that even sometimes on the subset itself there are some gray area, room of interpretation, and which is the work we are doing with the working group to make it more explicit. In fact, what is important is to have the control of the process. And this is why the role of ISO 17025 labs is important there, because thanks to their independency, they can, let's say, anonymize the issues from X, Y, or Z supplier and give a feedback to the notified bodies and to the European Commission, the ERA, and so on the fact that, this test case is not written adequately, for example. Yeah. So there is a kind of regular improvement of the process. So if we think about the level of difficulty it represents, I would say that you can, just to give you a very interesting score, a very interesting range, the best performance we made about 3 weeks. So to deliver a test report.
Yes. Yes,
and
yes,
the worst case we had was about 1 year.
Oh.
But this is just to tell the more time you spend with a certain customer is somehow reflecting his capability of being compliant to the norm, in fact. And it's not the fault of Multitel. It's not even sometimes the fault of the supplier itself. It can be sometimes an issue on the norm. I'm talking about baseline 2 experience here. So just to give you a bit of insight, but
baseline 2, I don't think, sorry, I don't want to cut you off, but I think baseline 2 simply because it's not relevant for Australia. I don't think we need to go into baseline 2 things. I think what's getting clear, hopefully for everybody listening, is that interoperability to reach real interoperability for a project for railway solution, it requires work. And what I normally say in my ETCS training, yes, I was just getting there. So what I'm normally saying in my ETCS trainings that I'm providing is that you need to work on the bookends for interoperability. So if you have a project, you need to start at the beginning of the project and do your specifications with the aim of interoperability, and to involve all of the suppliers that you know of to make sure that they all agree on a set of specifications which has a chance of being interoperable in the first place. And then after they've done all their product development, all their delivery adaptation for the project, then at the end, testing and testing and testing. And that's where you guys come in. And this is where I see a lot of potential for the test tools of a company like Multitel to really help enormously in making sure that the initial specification of interoperability is actually translated into a real interoperable outcome. I'd like to summarize it here. Maybe one additional remark just for the listeners. I have invited you as a speaker to the upcoming CBTC conference, CBTC World Summit. Now, people may say, well, but Xavier is the ETCS guy. What does he do on a CBTC conference? Now, what I thought, and we had a bit of an offline conversation before, and your feedback kind of confirmed my idea that where I thought that ETCS has a much better or a much more developed testing infrastructure compared to CBTC, where CBTC everything is very supplier specific. It's much less standardized than ETCS, so it's much more difficult to come up with a proper testing environment for CBTC, specifically for the client. So my idea was, if we have a testing tool provider like yourselves with your vast experience, not just in ETCS, but also in the adaptations for CTCS and for KTCS in Korea and for different suppliers from everywhere in the world, I was just wondering to what extent this test infrastructure from ETCS and similar technologies could also be adapted for use in the CBTC world. So without giving away too much of your thunder for the conference presentation, I just wanted to let people know this is the idea why I was inviting you to the CBTC World Summit to present there and to see what your ideas are and maybe even concepts that you already have to improve the testing environment and the tool-based testing environment in the CBTC space, because I think it's a real gap there. And I think if somebody came along with decent concepts based on solid experience in a similar field, that may be an extremely high benefit for the entire industry. So with that, I'm really looking forward to our next interaction, which will be at the conference. So I hope that we could at least scratch the surface for ETCS today. I'm sure you could tell us so much more on probably just alone on the UK and what you're doing there. We could probably have another 3-hour interview, and maybe we will at some stage. But for today, I wanted to thank you for your time, for your insight. It was fascinating for me. I thought I already know a lot of what you guys have done, but the whole story of going to Japan, then to China, then to Korea, 3 of the what people would think most difficult markets in the world, and you've been there and you've done the adaptation and you satisfied the customers there. I'm extremely impressed by that. And I would think from an Australian perspective, if you guys can handle Japan and China and Korea, you will be able to handle Australia as well. No question asked there. Yeah. So thanks very much for your time.
Yes, thank you for your time too, Frank.
That was
It was
really nice.
A pleasure to talk with you, and I'm really excited to have some. Let's say to share my experience on ETCS and to expose what I think could be a benefit for the CBTC domain, in fact. Because
Fantastic.
there are so many similarities between the domains. We were talking about 20%, but that's for, I would say, the fact that they are different in terms of operational means, I would say. But
yes,
when we talk about
yes,
subcomponents, they are quite similar themselves. So a DMI is a DMI.
Yes.
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 An ODR is an ODR, but in the end, you have the radio system on the which is quite different also on the on the railway, and there are different initiatives there. I think we will have the opportunity to share this within your virtual conference. I'm really keen on joining this session, and thank you for this.
Yeah. I just, by the way, I just realized, and we're really running out of time. I just realized that there were a couple of other things that I wanted to ask you as well, but I don't think I open up this can of worms now. What I would rather say doing, and just to, well, as a little teaser maybe for what I hope can be a follow-up interview, I wanted to ask you about the new radio standard coming up, about FRMCS, and the potential for this radio standard kind of bringing together a little bit more ETCS and CBTC worlds, and what you can do there from a testing perspective. Don't answer this, because otherwise we completely bursting out the time frame.
The conference.
And the other thing I thought, which is a big topic today for all these computer-based train control systems and software-based train control systems, anything software in fact, is the whole topic of cybersecurity and what to do there. And I think just those two topics, like FRMCS and cybersecurity, probably makes up alone a separate discussion, a separate podcast episode. So if you would be interested in that, I would certainly want to do a follow-up with you in a few weeks from now, maybe after the CBTC conference.
Yes,
and then we would have another topic as well, of course, like some kind of a review of how the conference went, and maybe some kind of a summary what you presented there. So for the listeners, if you enjoyed today's episode, then I hope you will already be looking forward to another follow-up that I hope we can do with Xavier in the future. Today's episode was obviously very much ETCS centric, but I mean, this is obviously to do with the quality and the expertise of the guest, and I didn't want to waste the extreme experience that Xavier has in the field of ETCS testing by having them talking about, I don't know, public transport in Belgium, and we probably could have discussed this as well. Yeah, but so I hope you can live with a very focused and specific interview on the field of ETCS testing. And with that, so thank you very much for listening. If you can share this episode with your friends and colleagues, or just let them know about this podcast, especially if you work in the field of ETCS, I think today's episode is a real must listen to for anybody in the field. And as usual, see you next week. And until then, keep it simple and bye for now. Bye, Xavier.
Thank you. Bye. Bye, Frank.
Hi, it's Doc Frank here. Real quick, I want to let you know about one of the best CBTC trainings in the world, if not the very best, but you always need to be careful with superlatives. It's the CBTC Kickstarter online course. It consists of 30 video lessons. That's the 3 with the 0. In total, over 11 hours of training content, talking about everything from the basics of CBTC, current standards, the benefits of CBTC, the key functionality of it, the supply industry, application tips and tricks, lessons learned, do's and don'ts, case studies, arguably the most comprehensive training that you can find anywhere on the topic of CBTC. A few additional things that make learning easier for you that you may not find on any other online courses. One of them being an immersion plan that helps guiding you through the training course and progress it in a finite period of time instead of just having it sit there for months and months on end. There is access to an online study group where you can connect with other students who are doing that training course at the time and form learning groups. And after the training, you will not be on your own. There is an alumni community that allows you to ask questions about the course content on an ongoing basis. So it's basically education for life. You can register on my training portal, which is docfranktraining.podia.com/ CBTC Kickstarter online 2023. I repeat that, docfranktraining.podia.com/CBTC Kickstarter online 2023. Hi, it's Doc Frank again. I hope you liked today's episode. I like to keep it as simple as possible, so I only have one single request for you. If you like this podcast, please tell your friends and colleagues about it. That's all I want, because that's a service that I'm providing to the industry, and I would like as many people as possible to listen to this podcast and learn something from it. So please share, and until next time, keep it simple and bye for now. Thank you for listening.